Let's get started and introduce our first speakers. So Blake Shears is an immersive technology systems architect at Johns Hopkins Applied Physics Laboratory. He specializes in adapting commodity technologies for enterprise use, designing application systems architectures, and applying sound software engineering practice to research efforts. Blake's primary focus is on maturing highly experimental prototypes and approaches for use in lab-wide research and development efforts. Blake is joined by Ian Hughes. Ian is a senior software engineer in the Johns Hopkins University Applied Physics Laboratory, Space Exploration Sector, Ground Systems Control Group. He is a VR developer for the IMAP VR project and is interested in developing XR applications to support the space mission systems engineering lifecycle. He has previously given talks at the XR Symposium on lunar avatar and spacecraft harness fabrication in XR. Please welcome Blake and Ian.
All right, well, first of all, these aren't the right slides.
Yeah.
Yeah, so I'm going to talk about Apex today. I guess I'll just blab while we're waiting for these to switch, but the APL engineering experience. I'm very excited that we were able to do this because I think I've been wanting something like this to exist for about 5 years, probably longer for Blake. We really need some software that lets us collaborate very quickly in VR or elsewhere with 3D content. So the APL engineering experience is our answer at APL to be able to bring multiple users together and collaborate in an environment over 3D content in kind of for engineering context. So what is Apex? It's a real-time, multi-user, collaborative XR environment, specifically for the communication, assessment, and design of 3D problems and their solutions. So the way I like to describe this is it's sort of like Zoom for 3D content. We want to make it as easy as possible for anyone and any role without involving someone like an engineer like myself or Blake to bring in 3D content very quickly and collaborate around that. So having multiple people looking at the same things, making annotations, making changes, and then saving that data off and taking pictures of it and whatnot so that they can solve all kinds of problems across the enterprise. So it's not just about space, it's not about any specific sector. We want to be able to support everyone. And we've taken a very highly modular and standards-based approach. So the idea here is that we can, if somebody doesn't like our network stack, we can swap it out for something else. Nothing's really vendor locked in across the whole software. We're sticking with authentication layers that APL employees know. We're also sticking with places for data storage that everyone knows. So in this case, we're using things like Box. So if I want to collaborate with you with 3D content, all I have to do is have a way to share that content with you. So I use like Box or a network drive, and we have to get the content in the same place. So as long as we're using that as our security to pass the data back and forth, and then we're ready to go. All I got to do is make a link to a room in Apex, and then we can be ready to go and collaborate in XR. And it's designed to support the enterprise. So this is not about some software that I have to run or set up a server on my machine. We're going to support it across the entire enterprise. It's a server architecture that lets you very quickly just log in to the system and you're good to go, like as if you log into Zoom or your email or something like that. And of course, we can support classified use cases. We haven't done this yet, but we think that we could package the whole thing up and put it into a classified space and support whatever networking stack needs to happen there, because it's very, very modular and easy to move around. So this here is kind of our OV1, what we kind of imagine how it would be used. We have people in remote locations, so we're kind of showing multiple roles here, like an artist and an engineer and a project manager and maybe a program manager across many different states, or they could be in the same location. If we support AR in the future, they might be in the same conference room, but collaborating and making annotations about pretty much anything. So it could be a spacecraft, it could be doing some design thinking or empathy empathy building for you know, a Navy ship or something like that, which is kind of what's shown here. There's a lot of different use cases for that. So then there's the video is not autoplaying, so I guess we'll need to click on that. So then we have just a little video. Here's what actually Apex looks like. So
is this a, like
I guess there is sound,
instrument
so
on the
I'll
end
be quiet
here?
for a second.
Yeah, so these are the two sensors right here, right?
Okay.
So there's two sensors, one here and here. I mean, I think they're magnetometers, basically. I'm not sure, but so this thing is actually deployed. So, you know, in launch condition, you can see there's hinges here, like this spring right here, right? So this thing actually swings open, right? So it comes from this position and swings this way.
Okay. Yeah, I see.
So it actually fits like right in this spot right here between the panels.
Whoa, cool.
Anyway, so if you saw my previous talk yesterday, you know I also work with the IMAP spacecraft. So this just kind of shows you an example where we're kind of just making up like, oh, what if I wanted to explain to someone how the IMAP spacecraft works? And you can see here we are with the model of that. Mike, who I'm working with there, is in the UK. So this is a remote, we're remotely talking across the Atlantic Ocean here in real time, collaborating around this in VR. We can make annotations and you know, basically, we could also manipulate the model as well, but the video doesn't actually show that. So we think it's really good. And then, you know, you also notice we have the avatars that are animated. So, you know, it's very collaborative in that way as well. It seems like I can kind of see how we move around, and I can point at things and stuff like that. We have the inverse kinematics happening with the avatars. So with that, I guess I'll pass it over to Blake.
All right. So one of the things we talk a lot about here, right, is adapting commodity hardware and software, right? If we don't have to write it ourselves, we tend not to write it ourselves. If we can just go buy a proper headset or piece of software, then we'll do that. We don't want to compete with industry. We're not putting out product for the sake of putting out product. We're not selling anything, right? We are really focused on capability. But the problem is that the industry has failed us. We have had, we waited years and years, and we kept saying, oh, somebody's going to come up with this. It's so easy. It's straightforward. And the industry is just going to create this product where we can load our CAD models in, and then we can talk about them in multiplayer, and it'll be great. And then it didn't happen. One of the things that kept on happening over and over again, right, is we're talking with these startups, and the startups are trying to run really lean, and so they're pushing everything to the cloud because they don't want to buy physical infrastructure and architecture. And then, of course, for their business models, it's very good for them because then they get subscription licenses instead of one-time purchase licenses, but it also means that we have to use their cloud. And because of many of our security constraints and concerns, we can't just go use somebody else's cloud. We need to make sure that it's certified, it's high enough quality, that our data is safe. You know, the spacecraft are things that are fairly low sensitivity compared to some of the other work that we do at the lab. And so we can't just be putting our models on somebody else's server. And they keep asking us to do that. And, you know, we start talking about like FedRAMP certification and their eyes glaze over. They have no idea what we're talking about, right? The bigger companies, the large IT companies, again, they're a lot of times looking for that vendor lock-in, or they're doing the hardware lock-in, right? So they're producing software that only works with specific hardware. And that means that we can only use it in specific use cases where it's appropriate for that hardware to be. We want to be much more device agnostic. In the case of this, what you saw was two people in VR working together to discuss a problem, but it was recorded from my computer, which was just a desktop machine. So it was, you know, recorded from the perspective of somebody just accessing it on their desktop. You don't have to have a headset, right? And a lot of cases, you know, we're talking with vendors and it's VR or bust, which when we're talking about really using these kinds of tools in the real world isn't practical. People travel, you know, some people don't like headsets. They're not all going to be hopping in headsets. So again, that modular architecture that we're talking about becomes really important because we want to maintain device independence. Some of the companies are also focused on tools that are used by everyone. And if, folks have heard me talk before, if you say, oh, I'm designing this for everyone, you're really designing it for no one. Anytime somebody says everyone, you can just replace no one in there, and that's what you really end up with, right? And so they're just like, oh, we don't have a specific use case, but everybody's gonna like this. No, they're not. That's why we have mechanical engineers on our team, because those are the kinds of problems that we're trying to communicate and solve. We need to be focused. We know whose life we're trying to make better. And again, a lot of these companies don't understand our security needs. Again, they're just like, oh yeah, everyone will use this. They can just upload their data into our whatever. And that's not really great for us. Some of the vendors, I kid you not, like we had one vendor that looked like they were going down the right path. They had a tool, we had licensed it. They got to the point where we could start loading things into there, and we're talking about, government grade cloud certification for some of them. And they're like, you know what? Building this tool is really fun, but we really like NFTs. And our angel investors want to go chase NFTs, so we're going to go chase NFTs. Good luck. And we're just sitting there going, wait, what? But it's true. So the big companies, they want to lock us in. The small companies get easily distracted. And so we sat around going like, this tool isn't coming around. Some of the products just never got delivered, or, had major restructuring, and so their products got shifted into other departments, or you have to, bundle it with their whole, communication silo, and it really turned into a big mess. Some highly proprietary solutions again, and we're like, no, we want to make sure that we have something that we can use in almost any environment and with almost any device. So we said, we're going to look at the standards, and we're going to design a system properly from a software perspective to make sure that we can handle as many different devices and as many different platforms as we possibly can. And so, here's a lot of our standards and modularity stack. OpenXR helps us support any headset that we have thrown at this. Especially in this case, we're developing on Unity, and we're using the interaction toolkit for some of it. That's also highly modular and goes from device to device. So the Apple Vision Pro is not an OpenXR device. It doesn't have an OpenXR subsystem, but it does use Unity's interaction toolkit, which means that those portions of it, right, are using that standard. And so we think porting over to that device is going to be fairly straightforward. OAuth, this is a big one. One of the big things that we're doing with the application architecture, and I'll show it to you in a second, is that any place we could leverage the enterprise architecture, we absolutely did. So OAuth was one of the big uses for authentication. So essentially what we're doing is, many of you who have used a VR headset know, entering usernames and passwords in a VR headset is a punishment that is not fit for man nor beast. And we said, can we get rid of this? But the truth is, with OAuth, because we are running this application on APL secure devices, we're logging into the system with our normal just Windows APL credentials. And then we tie in with OAuth, and we have a device flow thing. And so now we just hit a button, we start up our app, and we press a button, and our app goes, oh, you're logging in, and I see you're on an APL Windows machine, and I know what your identity is, and here you go, software, here's the identity of the user of this application. It is fast, it is convenient, and it is secure, and it also means that our software never has to touch a username or password. Never enters the program that we're writing, so that when we start talking about, oh, how do we get this certified through security? We say, well, we're just using the enterprise authentication mechanism. We're not doing anything custom, and you literally cannot extract a username and password from our application because our application never sees them. That gets the green light. They love that, right? So we're leveraging the zero trust architecture that we're building out at APL. GLTF is a 3D model standard. It's a newer standard. It's not quite supported by everything as well as we would like. But support is improving rapidly. We think that this is going to be a big transfer format standard going forward. JSON is JSON. Very, very standard, supported by just about everything. And then Socket.io is a networking stack that's designed to be supported by a large number of devices, programming languages, and network modalities. So you can see right now we have Quest 2 Vive and PC Monitor, but really anything that runs OpenXR should be able to run this application. There might be some issues with the controllers depending on how the buttons are bound. The engine right now, we're using Unity as our main game engine, but because we're using these standards, we could, if we wanted to, if there was reason to switch engines, we could. And all of our infrastructure work would still remain viable and useful. Our data, really, we said we have three kinds of data. One is the room data. Who's in the room? Where are the models in the room? What are they doing? What are the state transforms for all of the room and the people in it, and then the model data. And then we also have the networking data, which is, we call it ephemeral data. It's the data that comes in, and then as soon as you get an update, you just get rid of it, right? So like player positions, where are the players' hands, right? You don't care where the players' hands were, you throw that away, right? And so just as people are doing things, that network traffic is sent to the other multiplayer people, but then it's tossed. Our data sources, Windchill is our PLM system that we use for a lot of the lab. It is very large and robust. It has been in place since, I think, the late 90s. I could be wrong. Pixies is a tool that we use, so we actually have a piece that communicates with Windchill, pulls the models out of Windchill, and then we can process them via Pixies, which helps us decimate them and make them game ready so that they can be popped into the headset and perform well. And that's done via file import. And again, the model data, the networking data, that all lives on existing access-controlled network technology. So we have system architecture here. So we can see the enterprise OAuth identity provider. In this case, we're using Okta, but we did also try Microsoft's Azure AD. That worked as well. And pretty much any OAuth identity provider should be able to work in this. We are using the device flow so that we don't have to enter any kinds of usernames or passwords anywhere because people are in VR headsets. That's what device flow is designed for, is for devices with few input options. Our VM infrastructure, so that's where our persistent data and our ephemeral data tend to reside. So our room data is on a room server that we have. We are examining the viability of actually having that just be considered file data on the shared network drive with everything else. And then our ephemeral data, that's the multiplayer data that we throw away. So we have a very simple server that is essentially, you have a room, anybody in that room, it's just echoing whatever data that sends it so that all players get updated transforms. Our IT infrastructure, again, that's our data sources and our model processors. So again, we're leveraging anywhere we can. We're just piggybacking off of the enterprise. And then we have our standard APL managed PCs, which has your display, the Apex client running, and then our network storage and cloud storage cache. So that's going to be box drive. So again, if one person on the team puts a file in box drive, everybody who has access to that box drive can see that. That's an existing way that we're used to sharing files. And so now sharing the 3D content and being able to add it into our 3D environment works pretty much the same as any other file sharing that we do. And so that, that's the coordination of that is managed by our enterprise cloud storage service. And again, so we're using box drive now. It could be a network drive, could be any of a dozen possible vendors that provide those kinds of services. So next steps, where are we going from now? So we have a system, it works, it goes. We will have a demo here later today. We have at least 2 or 3 systems that we're going to have up and running and hopefully in a multiplayer session. It's proven to be a pretty stable application. The architecture is good. So we're going to have that up and running. We do want to look at adding dynamic scripting. We've seen some really cool libraries capabilities where right now all of the functionality we have is things that we have imagined beforehand and that we have to manually code into the application. We would like to see a plug-in style architecture where, again, we have our secure box drives and whatnot, that those scripts, those plugins are in those box drives so that you can start loading dynamic behavior at runtime. So maybe there's a live telemetry feed that you want to bring into your app or something like that, that script can live in Ian's box drive, but maybe I don't have access to it, and so that when he's in the experience with his colleagues looking at some spacecraft, they can get telemetry feeds, and I, as another user in another system, have no idea that that functionality exists anywhere. We want to refine the user interface. It takes iterations. It's just software development, so iterations, user testing, there's more improvements that we can make there. We do want to add some more features and data sources. We do need to perform. We've already gone through one security audit. Again, we sailed past that really quickly because, you know, when we showed them the application architecture and said, yeah, we're not storing data anywhere that we're not already storing data that has been approved, they're like, oh, this is great. And they gave us a green light. We want to add an augmented reality mode so that we can have multiple users. We're actually working on that now so that we can have multiple users in the same physical location that can see each other and then have, you know, the models floating in front of them. And then we also want to look at a classified use case. We're looking to take this and going into more and more secure environments so that we can really test this out and make sure that this is solving problems in those types of environments. We think it's actually going to be, again, pretty straightforward to do. The only thing there is the ephemeral data servers getting that approved because that's the only thing that would be new in a classified environment and making sure that that piece is up to snuff. So I think that's it. And from here, Ian and I are happy to take questions. If you would please come up to the mic.
If this application is targeted for just general engineers and designers, there was an earlier presentation where people were saying if they can't get use out of it within the first 5 minutes, they don't want anything to do with it. With that in mind, like what are the pain points or the friction areas that you guys think you've addressed or you think you need to work on so that the users will not say, you know, this isn't worth it type of thing?
So the first one is how fast and easy is it to get just up and running and in a headset? And we've gotten that pretty good. Joining a multiplayer server and whatnot, we've streamlined that process a lot. I think the biggest friction point we still have and we want to continue working on is our PLM integration, right? It's just a wonderfully powerful system, but you know our Okta implementation is very, very new, and our PLM system has been around for a long time. So we want to really see how we can make those systems handshake better, so that it's a single identity and a single method of authentication throughout the entire process of getting the model, decimating it, and getting it in. You know, a lot of this work, a lot of the point of this app is that people can have these interactions and I don't need to be involved or Ian doesn't need to be involved. You don't have to have a subject matter expert. So that is our goal, is to get it to the point where, yeah, people can just pick up a headset, set up a room, you know, and just say, use this box folder as my room, and it just kind of goes. So that is continuing, you know, that user experience iteration, we're continuing to do that because you're right. If it's not readily usable, people don't have a lot of time to sit around and fiddle with it.
The AR capability as well. Mm-hmm. Do you have a time estimate when you think that might be complete?
So we are working on it right now. We are hoping that we will have a prototype of that at the end of August. That's our fingers crossed, because we're already building off of an existing app. And this whole development has been like a year. You know, this time last year, we were just doing our homework to say, is this even feasible for us to build our own solution? Is this problem as easy as we think? And the answer was yes. And so this year, we've been building it out. And so now moving it to AR does have some tricks, because you have to have like a shared origin for multiple people in an AR session. So that's the kind of the missing piece that we're working on right now, is figuring out how have a good shared origin.
The other part of that is we're also trying to avoid having to load the software on the device itself,
Right.
which is kind of like defeats the whole purpose of the security that we're building, is keep it on the APL machine or whatever machine you want to use it for, because loading it on something like the HoloLens, now you're kind of off into that domain and can't really have the same authentication and stuff like that. So we're trying to make sure we can remote to the HoloLens or some other device like that.
Incredible, thank you.
Yeah.
Yes, good morning. Great presentation. Jose Colucci from the NIST Manufacturing Extension Partnership. We kind of are the advocates for the little guys, the tier 3, 4, 5 manufacturers. Yesterday, I was with a meeting with an aerospace company, and they told us that that whole sector is going into a digital transformation. And I thought, what is that? Well, that means that everything related to what goes on a plane, from the little guy that is making a little piece all the way, obviously, to the big guy, has to be tracked digitally. I know this is like 2 levels below what you're talking about here, but is there going to be some solution for this little guy that doesn't have to invest a lot of money to be able to do that? Right now, they're talking about 3D, I mean, but you know, some of these guys still are looking like paper blueprints to be able to do that. So, you know, that's something to keep in mind, that these guys will not be able to invest or even hire an engineer to be able to be doing those transformations. So any thoughts on that?
So my opinion, personally, as an engineer, and my manager might shoot lasers at me for this technology isn't the APL thing. APL designs incredibly sophisticated, complex solutions to mind-blowingly challenging problems. And you know, Crystal and her team will be telling you about some of that like very soon, right? And some of the things that we handle are really tough. This software is not really tough. This is an enabler. And, you know, so I personally, you know, I would love to talk with our team more. There's hurdles we need to get to, but ultimately I would love to be able to start open sourcing some of the stuff or doing collaborations with other agencies so that we're not the only ones building it, that as an industry we can start building this out. So again, the smaller folks can get in there and then make the changes that they need, you know, especially if there's the dynamic scripting components. And then we're also talking about integration with Cameo and some other things we're using here at the lab, knowing that those aren't necessarily applicable, you know, across the industry. All right, we have time for one more quick one.
So I see the value in this tool for collaborators, sponsors, customers being able to, non-technical people, see the end product before it's built and weigh in. Do you feel that this tool offers anything compared to your current pipeline or tools for things like internal sprint review or internal model review? Would you see this being used internally to the team? How does that compare to your current pipeline?
So we've already started seeing some projects looking to use this to demo and use this as a means to communicate with their sponsors what they've been designing and building. So yeah, I mean, we're already seeing a fair amount of use of this.
I mean, like, I assume that as you're developing the tools internally prior to discussing with a sponsor, that you're hosting regular, you know, like, hey, this needs to be fixed, that needs to be fixed. Let's revisit this again. I can't give you 40 hours for that, so fix it in 5 if you can, otherwise we'll just show it. Do you see this being something that can be adapted to that, or is your current tooling preferable?
We're not designed for that right now, but you know, again, we're trying to make it as modular, and so that if there are times when somebody comes to us and says, we need this use case, and we have a budget to help you build it out, adding that kind of thing isn't terribly hard.